Alright, one of the important things you guys can do is understand what intercepts are. They usually have specific meanings. They're usually important parts of the graph. And we're, of course, talking about X and Y intercepts. Alright? So here's an example. If miners are exploring 90 feet underground, the miners ascend in an elevator at a constant rate over a period of 3 minutes until they reach the surface in the coordinate grid. The horizontal axis represents the time in minutes. So we know horizontal is time in minutes. That means right here they reach the surface from when the miners have started ascending, and the vertical axis represents the miners' elevation relative to the surface in feet. So here's what we know. What point represents the miner's elevation at the beginning of the ascent, right? So we know this point, right? We know when they haven't traveled up, 0, right? They're at -90. They're 90 feet below the ground. At what point represents the miner's elevation at the end? Well, it says after 3 minutes, 3, they've reached the surface of 0. So both those, you can see in here, they have a meaning for that, right? They didn't just give us, right? They didn't just give us intercepts with no meaning. These points, and generally when you graph something, these intercept points have really poignant reasons they're there. We connect the points. What is the point where the graph crosses the y-axis? Well, this is the y-axis, so that point is 0, -90. And what about the x-axis? That is 3, 0. Discussion. All right. The point where the graph intersects the y-axis represents the beginning for the miner's ascent. Will the point where the graph intersects the y-axis always be the lowest point on the graph? Well, probably no, right? No, right? I could be on a mountain coming down. Right? If I did that, and there's lots of other examples, right? I would start at the mountain and I'd go down in that situation. Let's keep going. Alright. So, this is kind of the reason everything works. Alright? So, it says the graph in the Explorer, right, intersected at 0, -90, and 3, 0. The y-intercept of the graph is the coordinate of the point where the graph intersects the y-axis. The x-coordinate of that point is always 0. So what they're saying is the y-intercept, boom, boom, x always equals 0. The x-intercept of the point is where the graph intersects the x-axis. The y value is always 0. So for the x-intercept, y is always 0. All right? So to find the x and y intercepts, all you really got to do is plug in 0. Look, here's an example, right? When I've got 3x minus 2y equals 0, to find the x-intercept, replace y with 0. So instead of saying 2y, we say 2 times 0 and solve. To find the y-intercept, replace the x with 0. And so instead of 3x, we say 3 times 0 and we solve. Let's do it here. Here we go. -5 plus 6x equals 60. To find the x-intercept, replace y with 0. So instead of saying 6y, I say 6 times 0. Well, 6 times 0 is nothing, so it goes away, and I get -5x equals 60. If I divide by -5, divide by -5, I get x equals -12. So the x-intercept is -12, 0, right? You could just put -12 there. To find the y-intercept, replace the x with 0 to solve for y. So instead of saying -5x over here, we'll say -5 times 0, which cancels out, right? -5 times 0 is just 0. You get 6y equals 60, you divide by 6, and y equals 10. So the x-intercept, you could just put 10, but I'm going to say 0, 10, so you kind of see what the x value is. That's 0, 10. Not the best 0, 10, but it is 0, 10. If the point 5, 0 is on a graph, is 5, 0 the y-intercept of the graph? Well, you know what? That's an x value, and y is 0. So we're going to say no, right? X-intercept. If there was a y-intercept, x would equal 0. So here we go. All right, here's 3. I'm going to get the x-intercept here, and then the y-intercept over here. So for the x-intercept, I let y equal 0. I'm going to say 8x plus 7 times 0, all right, equals 28. Well, that's just 8x equals 28, and we divide by 8, which x equals 24 fourths if I reduce by 2, which is 6. Well, wait a second. I shouldn't have said 24. I should have said 14 fourths. I can reduce even further, right? Which gives me 7 halves. So my x-intercept is 7 halves, or 3.50. My y-intercept is when x equals 0. So we do that. We say 8 times 0 plus 7y equals 28. The 8 times 0 cancels out, so we get 7y equals 28, or y equals 4 when I divide by 7. So, one more. Here we go. Alright. So I want the x-intercept and the y-intercept. And remember, you just do the opposite, right? This one, y is going to equal 0. So I go negative 6x minus 8 times 0 equals 24. That cancels out. We get negative 6x equals 24, or x equals negative 4. So my x-intercept's negative 4, 0. My y-intercept, I let x equal 0. So I go negative 6x minus 8 times 0 equals 24, which gives, oh, did I do that right? Oh, I should have let x equal 0, so that should be negative 8y and 6 times 0. Right? So 6 times 0 goes away. I got negative 8y equals 24, or y equals negative 3. So we got 0 and negative 3. And those are my two solutions. That's your first 2 pages. There's only 2 more pages to go. I'll talk to you really soon.